Well, hello there. This is KP, the Math G, on a nice, actually a warm December day, but it's a beautiful day today. We're going to talk a little bit today. I really like this lesson here. This is on projectile motion, and I want to talk a little bit about some questions that may be asked on the test regarding, or any test for that matter, regarding projectile motion. Let's get started. A projectile is fired straight upward. Its distance above the ground given by S at t equals negative 16t squared plus 48t, where S at t is in feet. Alright, so this is distance that we're talking about here. Alright, and t is in seconds. Okay? Alright, so this is what we might refer to as the distance or how far equation right here. So we're going to answer 3 questions on this side of the board, and then I think there's 3 more or so on the other side that we're going to look at too. A part says find I, the time, velocity, and speed at which the projectile hits the ground. Okay, so when this is, as you can tell just looking at this is a parabola. It is concave downward. The reason we know that is because the lead coefficient, the t squared coefficient, is negative, so it's going up and then going down. Alright, so just like that, as it should be, because it is a projectile that was fired straight upward. Okay, so that's the nature of this parabola. Okay, it is a parabola. Now the thing we need to look at now is we want to answer this first question. Find the time at which the projectile hits the ground. Well, the time at which the projectile will hit the ground, can you agree with me, is when the distance is at 0. After it's traveled its complete travel, it's going to fall to the ground, and that's at that point this distance is now 0. Okay, alright, well, let's do that. Let's set S at t equal to 0. Alright, we're answering part I, and that's negative 16t squared plus 480t. Alright, so there's a couple things that we could do here. We could factor out a negative 16 when we're solving this. Okay, that would be probably, as a matter of fact, a negative 16t. Let's do that. So 0 is equal to negative 16t times t, I want to say that is 30. 16 times 3 is 48, and 16 times 30 is 480. And just remember, we took out a negative, so a negative times a positive is a negative, and a negative times a negative is a positive. Alright, so we're going to set this equal to 0, both of these. So negative 16t equals 0, which means that t is equal to 0. Well, we don't want that one really, because that's when it begins. At time t equals 0, it hasn't been projected up yet, hasn't been fired yet. Alright, okay, so that's not really what we're looking for. We are looking for the or side of it. T minus 30 equals 0. So now, solving this, we have t equals 30. Since this is in seconds, so it takes, so what are we saying here? It says, the question is asking, it says, find the time, that's the first part of it, at which the projectile hits the ground. It takes 30 seconds for this projectile. In other words, the projectile is going to be in the air for 30 seconds. All right? And finally, it hits the ground at t equals 30 seconds. That answers that one. So I'm just going to leave this. I can't turn the board over because I've got more questions on that. So let's leave I as t equals 30. I'm going to erase this I here. T equals 30 seconds. Okay. Now I'm going to erase this and we're going to answer the 2I. Okay. Alright, let's erase this. Bear with me. I know my board is just not that big, so 48 inches long by 36 inches wide. It makes for a big enough board though. I really like it. So anyway. Alright, so anytime on the first one you're trying to find how long is it going to be in the air, alright, when will it hit the ground, just simply set S at t equal to 0. We're not worried about velocity or acceleration at this point. We're just worried about when it's going to hit the ground. Okay? Alright, so after 30 seconds. Alright, there's that one right there. Okay. Let's answer number 2. What is the velocity? Alright, so we already know that it's going to take, this is talking about when it hits the ground now, that we're always answering at which the projectile hits the ground. We know it's going to hit the ground in 30 seconds, so we need to say then, let's get our velocity equation. Remember how to do the velocity equation? When we take the derivative of the distance equation, we get velocity. Alright, so S prime at t, let's do that first. S prime at t is equal to, alright, so negative 32 t plus 480. Now, what we want to do, this is actually v at t, so what we want to do is plug in place of t, v at 30, because that's when it hits the ground. Alright? So after 30 seconds, what is the velocity? And you think, well, Kp to math G, it is 0. Well, let's find out if it's 0. Alright, 32 times 30 plus 480. Alright, so I'm trying to think now. Let's see. We've got a 0 here. 2 times 3 is 6. 3 times 3 is 9, but it's a negative 960 plus 480. And I want to say that that answer is equal to a negative 480. And remember, velocity is in feet. Let's see right here, given by feet per second. Alright, so feet per second. Alright, so on number 2. Alright, 2I. V is equal to negative 480 feet per second. Why is the velocity negative, you ask? Well, because the projectile is on its way down. As long as the projectile is going upward, the velocity is positive. When it gets to the top, the velocity is 0. That's where we might say a vertex is, or a maximum is. Then it comes down, and so it's been coming down. And even after it hits the ground, alright, the moment that it hits the ground, it's at negative 480 feet per second. Keep in mind that velocity could be positive or negative. Okay? Positive going up, negative coming down in this particular context that we're talking about. Alright, so that's simple enough. So here, you got to find the derivative of the distance right here, and then you're going to find the velocity, v at t, but then, well, we already know what t is. 30 seconds. It takes 30 seconds to hit the ground. Okay, now, alright, so let's see here. I'm going to erase this. Alright, that's Roman, or number 2I. Alright, so here we go. We got this answer right here. Now let's go ahead and go down right there. That's fine. I have room now. Nice questions, aren't they? Now, the speed is just like the velocity. The third part is the speed at which the projectile hits the ground. Now remember, speed, this is the third. Keep in mind that speed is never negative. Okay? It is the absolute value of v at some number. Okay? Whatever a is. Alright? It's the absolute value of that. We're going to say that's a number. Well, we already know what v is. Alright? So here's the speed. The speed is equal to the absolute value of negative 480 feet per second, okay, which is equal to positive 480 feet per second. So the deal is on this one, if we get the velocity, we automatically can get the speed, can't we? Right? Alright, so it's just the absolute value of the velocity at whatever number it is. In this case, v at a would be 30. Okay, we already found that out just a second ago. Plug that in. Just take the opposite sign. Okay. If this is positive, be careful though. If the velocity is positive, so is the speed. Okay, because it doesn't take the opposite sign. Don't get us wrong on that. Don't get cross-wired on that. If the velocity is positive, well, the speed is not going to be negative. Okay? It's kind of like if I back up a car, if I were to back up a car 30 miles an hour, the velocity would be negative 30 miles an hour, but the speed would be positive 30 miles an hour. If I'm going forward 30 miles an hour, I'm going a velocity of 30 miles an hour, my speed is 30 miles per hour. Okay, that's the idea behind speed. Speed is not negative. Velocity can be negative or positive, either way. Alright? So keep that in mind. Alright, there are those three there. Well, I didn't want to stop. I mean, on those three, we're having way too much fun to stop now. So let's move on to some other questions. Alright, here we go. Whoa. I have some Christmas stuff back over here. Let's see if I can move it out of the way. Yeah, excuse me just for a second. It's not going to take long. Okay. There we go. Pardon that. I have a bed back here behind here, and I had a big old box. I've got Christmas stuff in that for my son and grandson, and well, son and his wife and grandson. Anyway, all right. Now, B part. When will the projectile reach its maximum height? Maximum height is that's the apex or the highest point. All right. of this projectile. It's going to reach its highest point, and all right, the velocity is fast, and it's going to slow down and finally get to zero. So this is when v at t equals 0. Now I have to go back and see what v was at the original on the last problem. Fortunately for me, I do keep up with my problems here. All right, so okay, v at t. Remember that was the derivative of s at t. So we found v at t already. V at t was equal to negative 32 t plus 480. And again, the whole thing, v at t, not when t is 0, but when v at t equals 0. Okay? Alright, so in other words, we're saying that 0 is equal to negative 32t plus 480. That's what you got to do when you're trying to reach its maximum height. Alright, always set the velocity, the whole thing, v at t equal to 0. Alright, it is not v at 0, it is the whole thing is equal to 0. Alright, so let's solve this. I'm going to bring this over to the other side. It's going to make this positive 32t, and that's equal to 480. Alright, when I divide both sides by 32, t is going to be some positive number, and let me see what that was. 15. And when you think about this, it does make sense, doesn't it? Because when barred that there's no wind resistance, okay, when we think about it, it's going to be up the parabola. It's going to make this path, okay, this far to 0 the same amount of time as it comes down here. So if it takes 30 seconds to complete the entire path, then halfway is 15 seconds, isn't it? So kind of think about that. If you already know how long it's going to take for the entire trip, on a parabola, it's going to be half that much, isn't it? So if the entire trip was 40 seconds, then half of that would have been 20 seconds. Okay. Alright, so it's going to take 15 seconds to get to the top. What is the projectile's maximum altitude? Okay, so altitude is how high up is it. Has nothing to do with the velocity. Alright, it's going to take t 15 seconds to get to the top, so it's got to be 15 comma something over here. Let me write it over here. 15, t is 15, and then the distance s at t, well, we've got to find that out. Alright, this is distance. Maximum, how high will it be? Alright, so what is its maximum altitude? So we don't go back to the velocity equation, we go back to the distance equation, because we're seeing how high this thing is going to be. Alright, so think about that when you're doing these types of problems. Alright, so what we have here is, alright, so s at t, remember we said that was negative 16 t squared plus 480. Alright, 480. Alright, so let's see. So we're looking at S. We want to, after 15 seconds, it's going to reach its maximum height at t equals 15. So it makes sense that we plug in 15 in place of t. We're going to square that. Okay. And I take it that if I did everything correctly on this, this is going to be equal to 36. Now, this is not feet per second. It's the maximum altitude, 3,600 feet. So you got to know what the units have to be. Maximum altitude is how high it's going to be. Okay? We already know when or how long it takes to reach its maximum height. Now we want to find out, well, what is the maximum altitude? Well, it's when t is equal to 15 seconds. We know that that's when it reaches. When is time. Alright? Altitude is how far. So we had to plug this back into the original problem here. Okay? The distance problem. Does that make sense? Alright, so I believe that is correct. When you think about that, 36, I think I did look that up, is 0.682, I rounded up to the 2, 0.682 miles. That's over half a mile high. It's actually over 2/3 of a mile high. Okay? So you don't have to worry about a jumbo jet getting hit by a projectile like this. Okay? I don't even know what kind of thing is being fired. I will tell you this, that it's probably not going to be a rifle. A rifle can go higher than that. Okay? And it's likely even a pellet will go pretty high itself. Maybe a BB, I don't know, but some projectile is being shot up. So that's a little over 2/3 of a mile high. Just thinking about that, I want to say that that's probably a little bit higher than the well, I can't remember what the name of it was. The Sky Tree, that's the name of it, in Japan. My wife went up the Sky Tree, which is actually I want to say a little over 2/3 of a mile high, 0.61, 0.6, yeah, something like that. I can't remember now. Anyway, it's pretty high up. It's about 2/3 of a mile high, almost that high. This is a little higher than that. Oh my! I never did. I'm scared of heights, so you're not going to find KP the Map G up there. There was a mall next to that. I stayed on the 4th floor of the mall, and that's about as high as I could get. Okay. All right. They enjoyed it. They showed me the pictures. Beautiful pictures. Those when you think about it, those buildings look so small from that height. My goodness. Okay. Let's answer the C part. What is the acceleration at any time t? Now remember, acceleration is the derivative of the velocity. So if you have the distance equation and you take the derivative of that, you get velocity. But if you take the derivative of the velocity, you get the acceleration. So we have v at t. V at t is equal to negative 32t plus 480. All right. And so what we want here is v prime at t, which by the way is a at t, which is, if you just take this derivative, negative 32. Alright, now remember, this is not feet per second, but it is feet per second, which a lot of people just say feet per second squared. It is negative. Why? Because gravity is pulling it down. Okay, so it's negative. Negative 32 feet per second squared. And so that's that. You know, there's probably other questions we could answer about this, but this is probably sufficient to help you gain an understanding of what equation to use and when to use it and how to use it properly. And that's the idea behind this. Okay, this is what I wanted to accomplish, and I believe mission accomplished. You know, so not to give myself any glory, you know, so, but the glory belongs to, well, anyway, who gave it to me. All right. Anyway, I hope and trust that this has been very helpful, very beneficial to you. And I've had to study this for some time to get where I'm at with this now. It is a beautiful. These are beautiful questions that I'm sure that somewhere down the line, one of these questions is probably going to be on the test. If you're in AP Calculus, if you're just in regular calculus, you may get all of these questions as just one part of the entire test. So anyway, once again, this is KP the Math G. Make sure that you do take time to hit the subscribe button. I do appreciate that. After I make the video, I do have a section for comments. I do wish that I could figure out how to get the comments going while the video is being run, but I don't believe I have that. So I just have to wait until after I process this video, and then I can get the comment section going for you. I do appreciate that. Any comments are much appreciated, and it may even help me do this better. All right, once again, KP the Math G. Have a wonderful day.